Okay, hi everyone. Today I'm going to show you how to use Pythagoras' theorem inside 3D shapes, and this can at times be difficult for some students. I think it's more just about actually visualizing the triangle inside that 3D prism. Here I've got a rectangular prism, and it's giving us the side length, so it's telling us that AB is 7 units, so AB 7 units. AE, so A to E is 4 units, which is also the same as BF, being a rectangular prism, and EH is, well, the height of our prism is 2, okay, which is the same as GF. Alright, the two questions that I've got here, I'm taking this one straight out of the textbook, sorry guys, is find the length of BE, leaving your answer in exact form. So we're going to leave it as a surd, and I'll show you how to do that, but it's basically just leaving out that final step. We're actually not working out the square root of that value. As I said, I think the hardest part here is actually visualizing which triangle to draw. So I'm going to sort of trace it out on this diagram. So we're finding the length BE, okay, which is the diagonal from here to here. All right. I do know that AE is 4, and I do know that AB is 7. So that's the triangle I'm going to use. ABE, with this being a rectangular prism, meaning that there is going to be my right angle. So basically, I'm just going to transform or draw that triangle just on a piece of paper, and I'll go from there. So let's just move that out of the way for now. I'm going to draw this freehand, sorry guys. So this was A, this was B, and E. Here's my right angle. And the lengths again I had were 7. Okay, for AB. AE was 4. And I'm actually going to work out the value of BE. So let's call that X. Alright, now if you remember back to my previous video, my first step, which is done, is to draw that triangle, a right angle triangle, label the sides, then go ahead and put in Pythagoras' theorem, which is a squared plus b squared equals c squared, and then label my triangle. So again, the hypotenuse directly opposite the right angle, that's C, and A and B are the two shorter sides. Again, it doesn't really matter which one's A and which one's B, let's call this A and B. Right, once I've got that, I'm going to substitute those values into the equation of Pythagoras' theorem. So instead of A, I'm going to use the number 7. Instead of B, I'm going to use the number 4. And instead of C, I'm going to use the pronumeral X. Okay, 7 squared, 7 times 7, 49. 4 squared, 4 times 4, 16, and that's equal to X squared. Now, I'm just going to simply add these two numbers together. So 49 plus 16 is 65. That's equal to X squared. So a number squared is equal to 65. Again, 65 isn't a square number, so it is going to be a decimal, but the question's actually asking us to leave it in exact form, okay? And you'll see that actually makes, the reason they do that is that we're going to use that measurement EB or BE for calculating the length of an unknown side in the next triangle. To make that more accurate, we're going to leave this in exact form. So X is equal to the square root of 65, and rather than going ahead and put that in our calculator, that's it. We're just going to leave it in exact form. So this is exact form. That's all we need to do. Or exact value. Okay. The next part of this question asks me to work out BH. Okay, correct to 2 decimal places this time. So BH is the diagonal from the bottom front to the top back. Okay. Here I'm going to draw the triangle EHB. I've just worked out this value here, BE, it's the square root of 65. I'm just going to use that value. We know that EH is 2, and we want to work out BH. All right, so let's go ahead and draw that right angled triangle. Again, I'm just going to draw it freehand, so I apologise for that in advance. Right angle here, B, E, and H. Okay, we know that EH is 2. We've already worked out that EB was the square root of 65, so let's go ahead and actually put that there like that. And in this case, we're working out the hypotenuse again. Again, let's call it y rather than x. Once we've done that, go ahead with Pythagoras' theorem, a squared plus b squared equals c squared. Then we're going to label our triangle. Hypotenuse is c. The two shorter sides are a and b. Let's go a over here this time and b over here. It doesn't really matter about those two, which one's a and which one's b, as long as we're labeling the hypotenuse c. Now we're going to substitute those values from the triangle into this equation. So instead of a, we're using the number 2. Instead of b, we're using the number, the exact value of square root of 65 squared. And that's equal to hypotenuse squared, or y squared in this case. Alright, 2 squared. 2 times 2 is 4. The square root of 65 squared is actually the square root of 65 times by the square root of 65. It actually cancels itself out. So if you do the square root of 65 squared, that's not going to work. Square root of 65 squared. No. Well, it's actually 65. And that's equal to y squared. Here I'm just going to add those two together. So that's 69. And that's equal to y squared. Y is then equal to the square root of 69. In this case, it's asking to correct 2 decimal places. So y is equal to, hopefully it works this time, square root of 69 is 8.3. I'm going to change that 0 to a 1 because I'm rounding up. Corrected 2 decimal places. Okay, it doesn't give us units, so no centimeters or meters. We're just talking about 8.31 units at this stage. Again, it's really just about following the process. I find that most people actually struggle with actually trying to visualize that triangle, those lengths that we're talking about. So actually, try and draw that and transpose that onto a piece of paper or into your books, and then just follow the steps. Once you've drawn it, label the sides, start with a squared plus b squared equals c squared, label your triangle a, b and c, substitute those values into the equation and follow the process to solve. Alright, thanks for watching and good luck.